Hi guys, welcome to DHARANI'S Max channel. Before going into this video, please like and subscribe for more videos. So the name and the background gives you that we are going to deal with max. So till this we have learned the set of numbers, that is natural numbers, whole numbers, integers, rational numbers. Okay. So do you check that I have missed irrational numbers? Yeah. Because for the definition of first four, if you get into that easily, it will be easy to find the next. So till now you have come across decimals, right? So do we see decimals in the set of numbers, that is in natural, whole, integers, rationals, etc.? We didn't. So that is the next number going to be, that is irrational numbers. But before going into that, let's check the answers for example 2. That is I have told to post in the comment box. So the answers of example 2, that is fourth and fifth rational number that you see here, are, so they can be 9 by 8, 5 by 4, 11 by 8, 3 by 2, 13 by 8, 7 by 4, 15 by 8. So these are the rational numbers between 1 and 2. If anything missed out, you know that you are correct, right? That's okay. So the next, that is what we are going to discuss in the video, is irrational numbers. So I have said you that irrational numbers are in the form decimal numbers. So here irrational is decimal and we are going to see briefly about it. So the next, that is definition of irrational number. Here irrational number is a real number. So what is real number here? That we will come to know. Let's see about irrational numbers now. That cannot be written as a simple fraction. Simple fraction is that 1 by 3, 2 by 3, 2 by 4, etc. That is a simple fraction. Irrational means not rational. Here irrational is not rational. Here why they have given as rational? Because rational numbers contain everything, that is natural number, whole number, integers. As natural number, whole number, integers can be seen in the numerator as well as denominator, right? That is why they have given that irrational means not rational. So irrational is completely different from rational, and these irrational can also be converted into rational at some cases. So here 1.5 can be converted into ratio by 3 by 2. So here 1.5 is a irrational number and 3 by 2 is a rational number. Okay. The next, pi. You know pi very well, and the approximate value of pi is 22 by 7. And here the value is 3.14159 dot dot dot. Here the dot represents that the number never ends, and here there is no bar upon this number. The bar represents that the number, that is the bar on the particular number. So if the bar is on 9, so this 9 will be repeating, that is 3.1415999 and goes on. So this is a non-terminating number, because while dividing, that is the value of pi is not ending, as here they have represented dot dot dot. So they are called as non-terminating numbers. So when dividing two numbers and the number that is not ending, so that number is called non-terminating. And non-recurring, that is this example, can also said as non-recurring. So non-recurring is that not repeating. So you know very well repeating the word. Here I said that if 9 has a bar on that, so it is repeating. So they are called as recurring numbers. Recurring means repeating. So here 9 is repeating, but there is no bar here. Just assume that there is a bar here and that bar on the 9. So that is 9 repeating. So they are called as non recurring number. So here no bar. So in the other hand, that is here no bar, they are set as non-recurring numbers. So this is non-terminating as well as non-recurring number. It cannot be expressed in the form of rational number. So irrational number that is non-terminating and non-recurring cannot be expressed in the form rational numbers. So the next is, how can we call this root 2, root 3, root 4, root 5, etc. in the set of numbers? How can we call this as in the set of numbers? So till now we didn't come across this, right, in the set of numbers. So this can be called as irrational numbers because root 2 value is 1.412. Here it is a decimal number, so it is a irrational number. So 1.412 dot dot dot, here dot is represented, so it is a non-terminating, and there is no bar, so it is a non-recurring number. So non-terminating and non-recurring, and it is a irrational number. So now we have learnt all the sets of numbers. So when we group all those sets of numbers, can they have a name? Is there a name to call them, all the group of numbers? Yeah, there is a common name to call all the sets of numbers, that is real numbers. So what are real numbers? Just see. So I have said that all sets of numbers can be called as real numbers. The next, this is the collection of rational and irrational numbers. So it is a collection of rational as well as irrational numbers. You know very well about both. So here they have given only rational and irrational. Why? Because there are more sets of numbers, right? Natural, integers, whole, etc. Why they have represented here only rational and irrational? Because rational have natural, integers and whole on the numerator as well as denominator, whereas whole numbers have 0 also, but the denominator should not be 0. So except that every rational, that is natural, whole and integers, can be seen on the numerator as well as denominator. So here the meaning gives that, so they are given as rational, and irrational the decimal form that you know well. So they are denoted with R, because here real number starts with R, so they are denoted with R. To make an easy understanding learning, I have said you this. Can be called either as rational or irrational. So this real number can be called as either rational or irrational. As rational, I said it contains natural, integers, wholes. So they are grouped and called as rational, and another irrational. So can we say that every real number is represented by a unique point on the number line? We can represent natural number on the number line, that is 1, 2, 3, and whole number on the number line, that is 0, 1, 2, 3, and integers also on the number line, that is -3, -2, -1 on the number line, etc. can be represented, as well as the rational numbers, that is 3 by 5, 4 by 5 and 2 by 3, etc. can be represented on the number line. You know very well. But how can the irrational numbers be represented on the number line? Yeah, they can be represented. Let's see in the next slide. But before going into that, so every sets of numbers can be represented on the number line. So there is a unique point on the number line for every sets of numbers. So every point on the number line represents a unique real number. So that number line can be called as the real number line, as it have all the real numbers, so they are called as real number line. So the next, you can see the flowchart of real numbers. Real numbers are divided into two, that is rational and irrational. Irrational can have natural, whole, integers on the numerator as well as denominator. That is given here. Integers are divided into two, negative numbers and whole numbers. Here whole numbers are divided into two, 0 and natural numbers. whole number has 0 and natural number that is 1 2 3 and 0, so that is called whole numbers. And whole numbers and negative, that is 0 1 2 3 plus negative gives you integers. So integers and non-integer rational numbers gives you a rational number, and rational number and irrational gives you real numbers. So that's all for this video. Thanks for watching. Subscribe, like, share and comment. See you in the next video.